So this is the fourth part of a four-part series sponsored by Multistack on advanced chiller designs. All the presentations can be found under training button on www.aeskc.com. As we are recording this, we are going to hold questions till the end, but please use the Q&A feature for questions. You can also use the chat feature. If you register and attend all four seminars, you're going to be in a drawing for a Traeger grill. So we're going to be announcing that and sending it out Friday, let everybody know who won that Traeger grill. And with the weather that we're having today, about 70 degrees in Kansas City, it sounds like it's grilling time. So there will be a short survey at the end. We'd like you to fill it out. It helps us present good seminars for you. If your company has a policy about no gifts, there is an opt-out button in our survey. Just click the no on that opt-out and we'll pull you out of that drawing. And there's a place to click for PDH credits and a copy of the presentation. So without any more, I think what I want to do is turn this over to Bruce Barrett, Regional Manager at Multistack on water-cooled modular chillers.
Thanks, Keith. All right, so fourth and final. I'm really pleased to hear it's 70-ish degrees in Kansas City. It's about, it's going to hit a high of about 50 today here. So absolutely grilling season. Wish you the best of luck on that Traeger grill. That's quite a prize. Thanks for sticking with all these presentations. Again, this is the concluding prezo. We're going to be talking about water-cooled modular equipment. Again, the first was MagLev technology on how that has advanced in different options. We proceeded to heat recovery and electrification. Last week we did air-cooled modular chillers, and it's kind of fitting that we're finishing up with water-cooled modular. That's how we started our business. 30 years ago, a 30-ton water-cooled scroll module was the only thing we produced. Today we have about 17 different products that we sell: air-cooled, water-cooled, scrolls, variable speed scrolls, mag bearing, of course. The industry's evolved, our company's evolved, and we've got a wide array of offerings to fit your HVAC challenges that you have out there. So we'll proceed with the presentation. We'll go about 40 minutes, hopefully, and we'll try to leave some Q&A time at the end. Again, here's our plant in Sparta, Wisconsin. Always important to note that we are an ARI certified facility. All the products that we list in our catalog, if there is an ARI certified program for it, we are certified. So what does that mean? It means we pay AHR to not only approve of our performance and our selection programs, but also certify our witness and test stands that we have in our facility in Sparta. So you guys are absolutely welcome to build that into a job, a zero tolerance, AHRI tolerance performance test. Simply come for a visit. We're very happy to have visitors in Sparta. Of course, with COVID, that's very challenging, but we take a lot of those steps to make sure that everybody stays safe. It's slowed down a lot, but we hope, you know, throughout this summer, we're going to have more opportunity to see more people at our factory. It's we have a good factory to showcase, and as we've shown over the 4 weeks, we've got a lot of different things to show. All right, so water-cooled modular. Why use it? Why is it important? It's very well, a very high percentage of our business, by the way. Still about 30% of our total $170 million in volume is water-cooled modular chillers. People are using them because the needs haven't changed. Redundancy, critical cooling applications, installation cost savings for retrofits, but also new construction jobs. You know, these difficult and challenging equipment rooms are not getting bigger. They're getting a heck of a lot more compact, and we can help with that. Future capacity and add-on, it's really simple with modular chillers. Very compact footprint. We can get really creative in mechanical rooms. One of the long-standing strengths is the low refrigerant charge of most of our water-cooled equipment, less than the ASHRAE 15 requirement for ventilation in the mechanical room. So that can be big dollar savings when your equipment is in the basement or up in a penthouse. Turn down. With modular equipment, we can turn down to 1 heat exchanger's worth of flow, that's pump savings, or the smallest chiller's compressor's capacity. So you can have excellent turn down on the refrigeration side and excellent turn down on the water side. Maintainable. By that I mean, if you lose a component, you don't lose the entirety of your chiller. So redundancy for us, N+1, 2N becomes much more footprint and cost conscious with the modular concept. And we've done a number of sound sensitive installations. We've replaced chillers in mechanical rooms, applied our acoustic panels to them, and allowed the facility to actually use space next to the mechanical room versus really blanking that out because it was simply too loud to work. One of the jobs we're very proud of is the Apple headquarters building in California. They use 14 water-cooled scroll arrays, 14 total arrays. There's about 8 chillers in each array. So if you think about the circle there, there's slices of the pie that are served by modular chillers. And why did they do it? California is very refrigerant conscious. They were very redundancy conscious, and they went with a water-cooled modular chiller because of the very, very low refrigerant charge and the redundancy that we inherently offer. To get some scale of this building, it's it's about 3/4 of a mile across. So it's a massive, massive building. So what is a modular chiller? It's multiple refrigeration circuits on the water side, piped in parallel. They can be mounted on a single structural platform. We can do that in our factory as well, pre-mount them. But typically, if you're going modular, you're trying to get it into a smaller place, through a 36-inch door, up to a penthouse, up an elevator shaft. All of these are controlled by a common master controller and typically linked together on the water side via grooved couplings. Very easy install. So let's talk about that redundancy component. We've done a number of changeouts or engineered solutions when we've compared a singular 500-ton chiller to an array of modular water-cooled chillers. And doing the calculations of refrigerant charge, example, a 500-ton chiller would have approximately 1,400 pounds of refrigerant. The same capacity of a modular array would have about 540 pounds of charge, with the smallest circuit being 45 pounds of refrigerant. So I haven't run into a mechanical room yet that has had modular scroll chillers on braze plate heat exchangers with that very small micro charge that has required the ventilation component to comply with ASHRAE 15. We'll talk a little bit more about that later. Also, that 500-ton machine turn down. If it could turn down to 10, 15%, say it has a variable frequency drive on it, that might be 150, 200 tons minimum turn down. On a modular chiller, you're able to turn down to your smallest compressor size. So 6 85-ton modules, it's about a 40-ish ton capacity. We can turn down to 20 tons of capacity, so tremendous turn down. Clearances. A shell and tube machine can have a very, very large footprint, not only side to side, but above. Modular chillers are very short, compact. We can move them around corners, move them around poles. Structural components, that can be easily done by just providing a spool piece to span that gap around a pole. So we've done a lot of those where there's installation challenges based on the mechanical room. Getting a module, say it's up to the penthouse or into the basement, these can be put on a freight elevator. Regular elevators typically will meet the weight requirement. Put them on a hand cart, pallet jack them around the building, stack them, connect them victolically together, and you've got a 500-ton chiller built. Just another quick example. This happens to be on the right-hand side, our new shell and tube modular mag bearing product. We blended a 140-ton module with 320-ton modules. My refrigerant charge is greater on a flooded machine. It's about 1,000 pounds. But we've seen flooded chillers gain, be up to 3,000 pounds of charge on a single set of shells. So it's still a refrigerant reduction. It is a little more challenging with 134A refrigerant to comply with ASHRAE 15, but it's worth doing the math. We'll go into that calculation in just a little bit. Turn down, once again, a modular mag bearing, each compressor, let's say that 120-ton compressor can unload to about 20 tons of capacity. So 20-ish tons versus a minimum turn down on the single set of shells of about 200 tons of capacity or 150 tons of capacity. It's a dramatic difference. Also, the flow changes, minimum flow requirements. We can unload to 1 module's worth of flow, 336 GPM using the 10-degree delta T rule of thumb versus 600 minimum flow GPM. Pump energy is real. That turn down is important both on the compressor side and the pump saving side. Real job we did in Topeka, 500-ton change out. Granted, it was a very, very old chiller, it had oil in it. It was very oil logged, lost a lot of capacity over the years, given the amount of charge that would migrate to the condenser side of the machine. They'd continually have to add more oil. That machine, when we watched it run on the hottest day of the year in a full load building, 102 outside, 90% humidity, hot Kansas day, 1.5 kW per ton, real. Terribly, terribly inefficient. That machine weighed about 30,000 pounds. Every time the compressor turned over, it would shake the entire floor of the building. It was replaced with 4 85-ton modules. A lot less capacity. How were we able to do that? Well, we did the calculation of capacity on the hottest day of the year. You do that by taking your delta T, your flow, and divide by 24. Delta T times 24 divided by delta T times GPM divided by 24. And the math said that we needed 4 85-ton modules, less capacity than 500. When we did the startup, we carried the entire building with a full 10-degree delta T. Absolutely quieter than the previous machine. They're able to lease out space in that penthouse now, next to that penthouse, not nearly the vibration. Much, much quieter as well. 40% energy savings right off the bat. Braze plate, even though they do have an oil component, they do not oil log like a shell and tube machine does. So fantastic change out. Great piping job there, by the way, too. The change out, by the way, did not require refrigerant ventilation in that equipment penthouse because of our 45 pounds of charge in each circuit. So the ASHRAE calc is based on the largest refrigerant charge. So it's 45 pounds. Well under the requirement in that large mechanical room. All right, the ASHRAE 15 requirement, what is it? Well, for 410A, it's 25 pounds per 1,000 cubic feet in your largest refrigeration circuit. So 410A, I just don't know if there's any math out there that you would ever require refrigerant ventilation or compliance with ASHRAE 15. For 134A, it's 13 pounds per 1,000 cubic feet of equipment room space. So there you probably got to do a little more precise math to figure that out. But I've run into that as well, where we've got a series of modular chillers with all the same amount of charge, and they've also been under that requirement. So if you're doing a retrofit, that could be a big deal. The equipment room may not have it because it was well before that standard. You might be able to save a lot of money using a modular chiller, even though it has 134A. Tight equipment rooms, accessibility. We're redoing the doors in our house, so I had to use the picture that my wife had picked out for the doors. So 36-inch door. Vast majority of our water-cooled modular equipment are less than 36 inches wide. Some are 32 inches wide. We've even done custom designs that are 26-inch wide modules. Again, they stack very easily together in the mechanical room, whether it's the basement or the penthouse. Save the equipment room for other things. Always looking for more space. We do a lot of these jobs where it's a build-out scenario. They don't have all the space leased out in the building. They're charging the customers for their usage. Once they get more customers, more tenants, they plan for that add-on of an additional module. And it's super easy to do that. Tie into a new or the existing power source, run some control wiring, 4 Victaulic couplings, and you're done. Critical controls. We do comfort cooling. We absolutely do a lot of critical cooling. Data centers where they are constantly looking for redundancy and backup if a component fails. And just as our air-cooled we did last week, we offer this fail-to-run mode component to our water-cooled modular chillers. We want to have no single point of failure. So we've added a flow switch to every module. We've added a phase monitor to every module. We're not relying on that singular item for failure to bring your entire chiller plant down. We also add software. If your master controller burns up, our slave controller will take over making chilled water out of that module. So if you've planned for maybe an additional module or two, add the fail to run mode component, or we call FRM, phase switch, phase monitor, flow switch, and software. You can have your chiller plant run even though you've got a single component down. Scroll compressors offer a very fast restart opportunity. So it's simply as fast as we can go is 5 seconds per compressor. So if I have 10 compressors, I can be at full load in 50 seconds. Very fast, back to full load. Another example of just about every component of a modular chiller retrofit is a 1,000-ton job we did. Pershing Square, I believe, is the 17th floor penthouse, had a very, very large existing chiller. These 80-ton modules were brought up through the service elevator, stacked in the mechanical room. Very low refrigerant charge, did not need ventilation. Super quiet installation. There's now panels on these. You cannot hear the compressors run. All you hear is pumps. This low refrigerant charge, we dropped it almost a fifth of the existing charge. They were able to get tenants that would get lead points given the amount of charge in the mechanical room. So that was an unforeseen bonus, dropping the refrigerant charge. 3-day startup, 3-day install. Very, very proud to have this job locally in Kansas City. It's a nice looking, excellent functioning job. Accessory modules. We have a large custom component to our business to serve as a pre-engineered plug and play. Set the parameters for us, give us some footprint requirements. We can pre-engineer not only the chillers, but the supporting accessories that are required on this job, whether it be a buffer tank, strainers. This one happened to be a process loop that had an intermediate heat exchanger, primary, secondary configuration. We provided all the pumps, all on one skid with the buffer tank, shipped it to the job site, installed, connected, pre-engineered all together. We've even done custom paint for customers that want it to match the infrastructure or the theme of the building. That's very inexpensive for us to do. All right, so we're going to go through some different models that describe our offerings. The most common is our scroll compressor, 10, 15, 20, 30, 40, 50, 70, and 85 tons. Those can be stacked all together up to 14 modules. They are braze plate heat exchangers, 2 independent refrigerant circuits. They do have electrical isolation. Not sure if you can see my cursor here, but you can power off individual modules and not disrupt the rest of the array. Again, very compact footprint. Same models we use a lot for our heat recovery chillers. We do offer a shell and tube condenser bundle. It does change the footprint dramatically. That's one of the bonuses of braze plate is you can get very, very compact. Shell and tube is going to get larger. Within that family, we've improved our product over the years to make it more accessible, more maintainable in the field. So the left is our old design, the right, our total access design, has the header pipes down the middle, has the heat exchangers on the outside. You can easily sit on a bucket here, isolate electrically this module, power it off for safety. I can pull a variable flow valve off. I can pull a heat exchanger off by isolating that water circuit. I can back flush heat exchangers one at a time. I don't need to do them all at once. I don't need to take my chiller plant down, but that makes it completely serviceable from the outside of the unit. This is probably 95% of what we sell now is the total access design, just because of the ease of maintenance. We do have extended header offerings. We do these a lot when we're starting to compile a pre-mounted skid. The piping's a little further apart. It's a little easier for us to work with. On here, we've got pumps on the right-hand side of the palletized, or we call it a lifting frame. The drives are in the gray panels on the right-hand side. And we ship this as a pre-engineered product, right down to gauges, temperature sensors, whatever's required or requested by the customer. On the right-hand side is 1, 2, 3, 4, 5, 6 modules on an engineered pre-assembled skid. So you don't have to necessarily get them one module at a time. This one, they had a large service room. They would wheel these in with a couple of hand carts or a forklift and drop it into place. You save a lot of assembly time putting these together with that lifting frame. There's a lot of concern out there for braze plate heat exchangers and debris on open systems getting into your heat exchangers. One thing we have done is added an inline strainer to the entering water connections on both the condenser and the evaporator side to keep that debris from getting into the heat exchanger. Now, we still require an external heat exchanger, external strainer. You want to capture it before it gets into the chiller. But just another added line of defense. Another item we've added is we call it a multi-flush. It's a debris removal system. We add an additional header on there. There's a solenoid valve that is controlled via our master controller, and every night it will dump some of that water, push the debris down to the end of the machine to keep it from fouling the entrance to the water pipe, from the water pipes to the heat exchangers. So 2 added levels of protection, inline strainers and this multi-flush blowdown system that helps keep your heat exchangers clean. Again, still require an external strainer on these machines. Water-cooled variations. So I'm going to talk a bit about variable speed compressor scrolls on our water-cooled equipment. Of course, we've talked about heat recovery. Air-cooled splits. We do a tremendous amount of air-cooled splits because they get the glycol out of the building. They're piped to a remote condenser. So a modular machine adapts very well to this, requiring small mechanical room chillers. Lastly, water-cooled condensing units in our scroll line as well. Custom applications. The green isn't very pretty, but the school wanted it painted their colors. Apparently they're lime green. That's about as close as we could get in PVC colors. It's a little bit different, but really shows off what we can do for, this happened to be a primary, secondary system, all pre-engineered on a skid right down to the buffer tank. Painted all of the steel components green, fully insulated. Put the skid on a truck, drive it down, put it in the mechanical room, connect your piping, connect power, and do the startup, and you're off. So we had to grow our line to get more opportunity for larger capacity jobs. And we developed our quad module. It has 2 tandem sets of compressors, and we go from 105 to 165 tons. We can get up to 8 modules together. It's about 1,320 tons of capacity. We do a lot of these for large geothermal projects, heat recovery projects, and of course, water cooled. Variable speed compressors. How do I know they're variable speed? They're blue. We happen to use the Danfoss line of compressors. They are limited right now to 50-ton modules. It is a great improvement in IPLV and water cooled jobs, about 20% better than fixed. Better temperature control, less compressor cycling, low inrush. It is about a 15-20% add, but if you're looking for tighter temperature control, very energy conscious, and still very low refrigerant charge, our variable speed offering is a great opportunity for you. Talk a couple slides. I mentioned capacity, the ability to slow down. Each compressor can unload to about 20% in a water-cooled environment. They do have an external drive. We do have to be conscious, since we have to mount that drive on the equipment somewhere, conscious about the footprint of the machine. If you got to get it through a 36-inch door, we've got some variations to be able to do that. What does that mean for a water-cooled job? Well, we could do single modules. We can do an array of chillers with one of those compressors being variable. It's going to be your first on, last off. We can add more compressors as variable. It's going to increase your ability to do tighter temperature control. Of course, we could do all of the compressors with variable speed. So we're trying to be cost conscious as well as efficiency, electrical conscious in applying that variable speed compressor. You do not have to go all in, all or nothing. I do believe with that variable speed compressor, you've got some excellent bonuses. The lowest inrush possible, having all variable speed. These do have direct driven motors. They have qualities of harmonics that are very good for applications where there's critical components shared on the electrical system. It's a great option. Don't have to go on-off scrolls. You can blend or go all in on true variable speed. It's just more efficient, better turn down, power factor, low inrush. There's a lot of benefits. The picture in my background happens to have 20 50-ton modules. That was Lincoln Electric Service. And they wanted all of those things because they're the electric utility. They understood all those benefits. So being able to absorb that cost for the benefits was very important to them. Next, a relatively new product line. We launched it about 1.5 years ago. It's our Msfm modular mag bearing machine. 90, 120, and 140 ton sizes. It's got flooded shells. It's not braze plate. As you can see in the picture, it does have stacked headers. Those are grooved connections. We call it our total access design. I can get to the components, the compressor, the valves. I can electronically isolate these. It's a great product for new construction or retrofits. I'll show some better pictures on the two-pole accessibility. You can really shrink your mechanical room down when you don't have to worry about those longer tube pulls. Extremely quiet operation, near zero vibration coming out of that compressor. And of course, our Flexus controls, which control compressors independently via a Modbus connection. So turn down, efficiency, quiet are really the big three. All right, so the picture on the right-hand side shows the condenser water box, which is hinged. So undo the bolts, swing that door open, do your tube brushing, annual maintenance. You can do that one at a time. You don't have to do them all at once. So it doesn't become a shutdown opportunity. If you have a low enough load, you can get in there and clean your tubes. The compressors that are shown in this picture are alternative refrigerant. We happen to be showing on this 1234ZE near zero GWP. We also offer 513A compressors. That's a standard option for us. And of course, 134A is our standard refrigerant right now. Just a quick drawing of how they stack together in the mechanical room. From our factory, we do stub out the refrigerant vent piping out of the top of the machine. So bring them in, groove lock couplings together. We'll provide the single point power connection via conduit if you so choose. And very, very quick installation, compact footprint, 42-inch tube pull on these machines. 42 inches, that's an aisle width. And slightly just about the requirement for high voltage clearance. So you can really stack a lot of these chillers in a small mechanical room and have them still easily maintainable. All right, getting close to the end. This is really a summary of what we have in our selection program. Water-cooled scroll modular chillers. They can be applied to geothermal applications, what we call our VME2 geothermal heater chiller. We do a lot of fluid cooler jobs. Modular chillers piped on the condenser side out to a fluid cooler. On the lower left, our water-cooled modular mag bearing, which is shell and tube. We're applying the same technology for heat recovery scrolls. We still have a brazed plate, 80 ton per module mag bearing offering, but it's really been overcome by our lower left modular shell and tube. It's much more affordable. I can get bigger quicker. Shell and tube is a lot more forgiving on water quality. So the shell and tube modular mag bearing has become a big product for us because of the benefits of efficiency, sound, small footprint, and easy maintenance. Water-cooled DX condensing units, still a big product line for us. We do a lot of those with shell and tube heat exchangers as well. The footprint gets a little bit bigger, but the application certainly for water-cooled modular chillers is very, very wide. So with that, I'm about 11:37. I'll look to the chat feature and look for any questions. Thanks for joining, really appreciate it.
Okay, let's see here. Unspotlight you here. Bruce, can you hear me okay?
Yes, sir.
Okay. I'm trying to unspotlight you there, but if you can hear me, everybody else can. We did have one question that came in through another way here. Do the MSF flooded modules still meet the low refrigerant volume to avoid a refrigerant ventilation system? Good
question. First calculation would be to calculate your equipment room cubic feet. For 134A, that's about, I have to go back, I'll go back to that slide. There we go. Nope, I lost it. All right. Need to move the chat feature, sorry. For 134A, it's 13 pounds per 1,000 cubic feet. A MSF 140 is going to have close to 300 pounds of charge. So it's probably unlikely that that mechanical room is going to be large enough, but you still have to do the calculation.
Okay.
13 pounds is not a lot for 1,000 cubic feet, but if you got a 20,000 cubic foot mechanical room, you have to do the math to figure that out.
Got it. We don't have any other questions. It's been a great series, Bruce. I want to thank you personally. I know we've had a wonderful group of attendees. I have a couple of housekeeping things just to go over. First of all these seminars are going to be available at the AES website. If you go to aeskc.com and click the training button, you'll be able to share these or look at these or kind of revisit those. We are going to do the Traeger grill tomorrow. We're going to draw for that, and then we'll send out a notice on who the winner is. So please fill out the survey after we're done here. Cross my fingers, the survey is going to work this time. But if you've attended, you're registered anyway. There are more great seminars to come from AES with other products, and probably even some more on chillers later in the year. We'll see. If you are interested in having other people or telling other people about our seminars, just have them log in or contact their AES salesperson, and we'll get you added to the invite list. So anyway, I just want to thank you all for being part of this seminar. I'm going to go ahead and close things up. And Bruce, thank you again. And we look forward to more great seminars and look forward to helping you on your chiller needs and on your HVAC needs as we move forward. Thank you very much.